Hello everyone, this is a homogeneous differential equation. Homogeneous means it is inseparable, that is the variables are not able to be separated. We need to separate these variables and we introduce a variable v here. Basically homogeneous equations are, in the equation the variable x and y are not able to be separated. So in order to separate this, we introduce this new variable v, and we substitute that in the place of y, substitute vx. Let us go to the question. The question is x minus y into dy by dx is equal to x plus 2y. On rearranging the question, that is bringing x minus y to the right hand side, that becomes dy by dx is equal to x plus 2y divided by x minus y. Substituting in the place of y, that is vx. On substituting vx, y gets eliminated and we get the new term v. So such that we differentiate at the next step. So dy by dx is equal to v plus x into dv by dx. That is our third step. On comparing the equations 2 and 3, the LHS are equal, so obviously the RHS must be equal. So equating the RHS of the equation 2 and 3. So equating the RHS, that is v plus x dy by dx, x dv by dx is equal to x plus 2y divided by x minus y. In this step the v is introduced. Why it seems in the place of y here we have substituted vx. So the equation becomes x plus 2vx whole divided by x minus vx. So we have eliminated v and we have got eliminated y, and in the place of y we have got v. Now we need to separate the variables v and x. So in order to separate, I am going to simplify the equation 4. So on seeing the equation 4, we can analyze that x is common in both the numerator and denominator. Take x common and cancel it.
Actually we are taking the GCD.
GCD, right. It is a GCD. So taking x common, that is 1 plus 2v into x and 1 minus v into x. Here the x gets cancelled and we get v plus x dv is equal to v plus x dv by dx is equal to 1 plus 2v divided by 1 minus v. So taking v to the right hand side, that becomes x into dv by dx is equal to 1 plus 2v divided by 1 minus v minus v. Again taking LCM and taking LCM, it becomes 1 plus 2v minus v into 1 minus v, that is minus v plus v square.
Here there is a chance of committing mistake. Can you guess the mistake?
Sir,
we will forget to take.
Sir,
LCM.
here we forget the minus 1 minus, we may put minus v square.
That is, we will forget normally the LCM.
Oh, forget
Simply we will
LCM.
take 2v minus v is equal to v. But this 1 plus 2v divided by 1 minus v is a fraction. Whereas minus v is a whole number. That is different.
Okay, so we forget the LCM.
So take care of LCM. Now.
We should take care of the LCM. We may commit mistakes there. So on taking LCM, the numerator is 1 plus 2v minus v plus v square. So 2v minus v is v and v square plus 1 whole divided by 1 minus v. Now I am rearranging this term, separating the variables x and y to one side and another side. So dx by x is equal to 1 minus v into v square plus v plus 1 into dv. There is some change of place to each and x goes to, so x is in numerator and go to the denominator here, and dx goes there, so this becomes dx by x, and the 1 minus v square plus v plus 1 whole divided by 1 minus v is reciprocated and brought to the left hand side, and it is written in a standard form, that is dx by x is equal to 1 minus v whole divided by v square plus v plus 1 into dv. So this is the fifth step. Next step, we integrate the equation 5. So integral of dx by x is equal to integral of 1 minus v whole divided by v square plus v plus 1 into dv. So on integrating ex by x, we get natural log of modulus of x plus c, the arbitrary constant, equal to I. I is nothing but that is equal to the standard equation. So we need to integrate 1 minus v divided by v square plus v plus 1. So considering the denominator of I, that is v square plus v plus 1. So considering the denominator, we separate it using the completing the square method. So the completing...
What is the general format of quadratic equation?
The general format of a quadratic equation is ax square plus bx plus c. So now we apply the completing the square method to the denominator of the I, that is the integral part. So v square plus v plus 1, in this on comparing with the standard quadratic equation, we get the values of a, b and c. That is a equal to 1, b equal to 1, c equal to 1, and we substitute in the standard formula. So the equation becomes, that is in the place of x we substitute b. So v plus 1 by 2 into 1 minus 1 square minus 4 into 1 into 1 divided by whole divided by 4 into 1 square. So on simplifying the equation, we get the final equation as v plus 1 by 2 whole square plus root 3 by 2 the whole square. Here we may commit a mistake that we may forget the minus sign here and we may write minus over here. So we may commit mistake, so we should be careful over in this part. So minus into minus becomes plus here. So the 3 by 4 is, 3 is nothing but root 3 the whole square and 4 is nothing but 2 square. So I have written it as root 3 by 2 the whole square. So we have separated the denominator into two parts. So substituting the denominator, and here the 1 minus v divided by v square plus v plus 1, I am separating the numerator and the denominator, separating the fraction into two parts. That is 1 by v square plus v plus 1 minus v by v square plus v plus 1 and bringing dv inside. So the I becomes dv by v square plus v plus 1 minus v by v square plus v plus 1 into dv. So considering this as I1 and this as I2. So and now I need to integrate I1. So in the place of v square plus v plus 1, I have got this, that is v plus 1 by 2 the whole square plus root 3 by 2 the whole square. Let me consider this as 7th step.
Yes.
8th step. So I am going to substitute this 8th step here. So the equation becomes integral of dv by v plus 1 by 2 the whole square plus root 3 by 2 the whole square. Here I am going to apply the integration formula. Integral of dx by x square plus a square equal to 1 by a into tan inverse of x by a plus c.
You can put the equation 9. I1.
So I am going to substitute the integration formula in the equation 9.
That formula is 10.
What is it?
So that should be 10. Now this 10. Okay. So using this formula you are integrating.
So applying 10 in 9.
Good.
So the equation becomes so the a is nothing but root 3 by 2 and 1 by a is reciprocal of root 3 by 2, that is 2 by root 3 into tan inverse of x is v plus 1 by 2 and root 3 by 2 is the a. So x by a plus c1 the arbitrary constant. So taking GC, that is taking LCM 2v plus 1 divided by 2 and root 3 by 2. So denominator gets cancelled, so we get 2v plus 1 by root 3. Here we should not disturb the root 3, it may help in the case of tan. So no need of rationalization, it should be such as root 3. Now dealing with I2. So in I2 the equation is integral of v by whole divided by v square plus v plus 1 into dv, that is the step 12, that is separating I2. So in I2 we multiply and divide by 2. So on multiplying and divided by 2, here the 2 goes to numerator and the 2 in the denominator is taken outside as half. So here and we are adding plus 1 and minus 1. So why it is done? let us consider v square plus v plus 1 substituted to a variable t.
So that is the substitution technique.
Substitution technique. So on differentiating v square plus v plus 1, we get 2v, v square applying power we get 2v plus 1 equal to dt. That is into dv is equal to dt. So in order to bring 2v plus 1 in the numerator, we multiply 2 and also add and subtract minus 1. Next we are separating 2v plus 1 and minus 1 with separate denominators. That is 2v integral of
You
half
are splitting
is
this into two fractions.
that is splitting into two fractions. That is half into integral of 2v plus 1 divided by v square plus v plus 1 minus 1 by v square plus v plus 1. So substituting 2v plus 1 into dv is nothing but dt, and v square plus v plus 1 is equal to t. So this is equal to I1. How it is? We have considered integral of dv by v square plus v plus 1 initially as I1. So bringing back I1 in I2. So that becomes minus I1. So bringing the half inside and integrating dt by t. So that becomes half into natural log of modulus of t minus half I2, that is half I1, that is equal to I2. So I is nothing but I1 minus I2. So I is equal to I1 minus I2 is substituting I1, that is 2 by root 3 tan inverse of 2v plus 1 divided by root 3. That is minus bringing back I2 here and substituting.
No. That is, instead of substituting individually, first we solve I1.
Okay, sir.
In terms of I1, let us solve. So it becomes I1 minus 1
So
by...
solving in terms of I1 and then substituting.
Finally you can substitute.
I1 plus 1 by
So
2.
I1 minus substituting I2 here, that is minus half natural log of modulus of t plus half I1, and then grouping I1 and half I1, that is taking I1 in common 1 by 2 plus 1, that is 3 by 2 I1 minus half natural log of modulus of t. So I1 is nothing but from here we get it as 2 by root 3 into tan inverse of 2v plus 1 divided by root 3 minus half natural log of v square plus v plus 1 plus the arbitrary constant. So from here, so I is equal to, and cancelling 2 here, we get I is equal to root 3 tan inverse of 2v plus 1 by root 3 minus half into natural log of v square plus v plus 1 plus c. Now we have to go back to the equation. Yes. Now going back to the initial equation, I is equal to natural log of x plus c. So what is our I? Our I is root 3, that is the equation 16. So substituting I over here, that is, let us take this in left and this in right, and natural log of x plus c is equal to root 3 into tan inverse of 2, and substituting that we substituted y is equal to vx, right? So we need to substitute v is equal to y by x. So I am going to substitute v in place of v, that is substitute into y by x plus 1 divided by root 3 minus half of natural log of modulus of y by x the whole square plus y by x plus 1
Plus 1, then modulus.
plus 1 then the modulus. So the
Plus.
already our constant introduced. So our final answer, this is our final answer.
Solution. You can cancel it. Actually, this is the final solution.
This is general solution. So
you can remove that c. On both sides it can be of two different integral constants. Is it not? So you can remove totally.
So no need of c over there. Sir, why no need of c, sir?
You can put the c on one side.
So
That is the final constant.
so
Then it can be c1, this can be c2, c1 minus c2 or c2 minus c1. Ultimately it is c.
so you can do the
You
c
can
over
put
here.
simply plus c. Otherwise what you can do on the left side you can introduce as an arbitrary constant c1, right side is c2.
So c2
if you
minus
bring
c1 is
this
considered
c1
as
on that side it becomes what?
c.
c.
Totally c.
c2 minus c1 is nothing but c.
C.
So simply introduce c, that's all.
So final answer is natural log of x is equal to root 3 tan inverse of 2 into y by x plus 1 divided by root 3 minus half natural log of 5x the whole square plus y by x plus 1 plus c. No need of simplification here.
Suppose if you have got logarithmic functions on both sides, then
Log
instead of
C.
c you have
Log
to put
C.
log c.
Log is
But here it involves different types of functions like logarithm.
inverse
something like that.
trigonometric
Okay, so you can
logarithm and
maintain this.
logarithm. So
Okay.
thank you.
Okay, good. Now that is, if there is any question you can discuss. Any question? And what are the key steps involved in this problem?
Key steps.
Can you recap so that it will be very useful to the students who are observing this,
So
watching
key
this.
steps is first is rearranging the term, rearranging the question. The first we did it.
Rearranging the homogeneous differential equation. So when you rearrange the homogeneous differential equation, you will be struggling for separating the variables x, y. And that is why you take y is equal to vx. Third step, differentiating y is equal to
That
vx.
leads to phi of v.
Fourth step,
That leads to phi of v.
what is the fourth step?
Phi v.
Fourth step.
Phi of v.
Phi of introduce upon.
V y is equal to vx. On differentiating it, we get as
Now y is equal to vx, that is the one. On differentiation you are
We are
able to
getting
get
equating 2 and 3.
e equal to 2 and 3. Fifth one?
solve and
So
integrate.
separating the integrals and solving it.
Okay, separating the variables.
Yes sir.
Like
SEPA,
Separa.
separating, PA. So separating the variables now. Then integrate. So during integration, we adopt certain techniques.
Integration technique.
One is integration techniques. And what are those integration techniques? Completing the square.
Applying formula.
Substitution.
Then followed by,
A square minus x square formula.
yes, completing the square technique. You can,
Completing
and
square
then
method.
introducing the formula. That is
A square minus x square. Dx
Yes.
by x square plus x square.
formula
Substitution.
dx by
So formula.
X square plus x square.
dx by x square plus a square.
So need to mention it.
You can mention that integral dx by x square plus a square. So that is a very important formula. And what is that? Completing the square method formula. You can also introduce that one, so that will be very useful for us. You can write down. You can write on the right. Erase the right part. So what is that? Completing the square.
Sir, I
technique?
mentioned over here, sir. Right to the right.
So that is x plus b by, put x properly, x plus b by 2a. You should never forget this. And we also, I think we already discussed in previous videos about the conversion of this quadratic equation into a,
Differential.
by completing the square root.
Substitution.
sir, and then component of dividend.
Okay?
Oh.
Then we have done like that. Substitution method we have done.
Then multiplying 2
And
divided by
in the substitution, that is, we did some gimmicks, like that is multiplying and dividing by 2. So you should not forget that step. Second one, adding and subtracting by 1. Adding and subtracting by 1. What is the purpose? So that you will get that v plus 2v plus 1 term, so that can be conveniently separated. Again, there will be a splitting of fraction, is it not?
yes,
So
sir.
fourth step, splitting of fraction. Fourth one, put Roman letter. No. Splitting of fraction.
Within integration, these
Within
substeps.
integration, we adopt all these techniques.
And then cyclic integrals, sir.
So we introduced 2i1, I1.
I1 plus 1 by 2 I1.
I1 becomes cyclic.
Solve.
And finally, we solve.
Replace V.
That is the 7th step, is it not? Put 7. Good. So these are the 7 important stages in this problem. Okay?
Replace V. Replace V
replacing
by
V.
X.
Most
Final
important
solve
step.
Replace V by
V is equal to Y by X.
good. Very good.
Thank you, sir.